Today's presentation is Improved Workflow and Expanded Functionality of RsNLME version 1.1. Our speakers today are Dr. Keith Nieforth and Mr. James Craig. Keith is currently a Senior Director of Pharmacometrics Software at Certara, where he has more than 30 years of global drug development experience. Keith earned his Bachelor's of Science in Pharmacy from the University of Connecticut and his PharmD from the Massachusetts College of Pharmacy. James is currently an R software engineer and Shiny developer at Certara. He has over a decade of experience developing R packages. Prior to Certara, James worked on various software applications in real estate and political analytics. James and Keith, welcome to today's event. I'll now turn it over to Keith to begin the presentation.
Great, thanks, Suzanne. And everyone, welcome. I'm glad you've joined us today to learn a bit about RsNLME. I'm going to turn my webcam off. I have a lot of real estate I've got to work with today in the demo and the presentation. But yeah, I hope you enjoy the talk. And again, thanks for taking time to join us today. Okay. Bring my slides up. Does that look okay, James?
Looks great.
Great. Okay, so today we're going to talk about improved workflow support and expanded capability that can be achieved using RsNLME. In today's talk, we're going to talk about using RsNLME with an R solution known as R Markdown. Just very briefly, some webinar logistics. This is a 1-hour webinar with Q&A at the end. All attendees will be muted, and you can use the questions panel to ask questions. So we'll have some time for questions at the end. Looking at the topics for today, I'm going to give a very brief recap of the strategy behind RsNLME. Why did we build this? What are the benefits from its use? And then we're going to dive into a demo that shows efficiency gains that can be achieved using RsNLME with an R package known as R Markdown. And that will be the focus of the demo, how to use RsNLME in parallel with R Markdown to add quality and efficiency to your reporting workflow. So what is RsNLME? RsNLME is a Certara supported environment for pharmacometric work in R using Certara's NLME engine and pharmacometrics modeling language PML, which is the same language that's used in Certara's Phoenix platform from modeling individual data in WinOnLin into Phoenix NLME, and now you can bridge that into R using the same exact syntax. Key workflow steps in recognition of the fact that R can be a difficult language to learn are supported by intuitive Shiny apps that we built. And these applications allow you to either complete that key workflow step through a Shiny app GUI, if that's the way you prefer to work. However, the GUIs that we've built also return command line code in R, so they can be used to do the job or act as a starting point to generate code that can be further customized to your particular analysis problem. So yeah, okay. So again, people ask me why we built RsNLME, why the focus on R. And really, it's all about extending the capability of our pharmacometrics tools and also to help users and organizations realize the benefits of R in their PMX workflow. From the user perspective, of course, I don't think it's disputed at all that there are tremendous efficiency and flexibility gains that are possible with the use of R. However, R is hard, and the way we built RsNLME helps to lower the learning curve. I mentioned the GUI Shiny apps, tools that teach is the concept there. And using the suite of Certara solutions, a user can gradually transition from modeling in Phoenix into R with familiar modeling syntax. And in addition, we offer RsNLME free to students in academia, the idea there being that students are able to begin learning on tools that industry uses. And more, particularly junior staff members that join our own organization are skilled in R when they come in, and that's really changed over the last few years. From the organizational perspective, It's all about providing full scope scalable solutions. So if an organization has the combination of Phoenix, RsNLME, plus or minus Piranha. Piranha is a pharmacometric modeling workflow management tool that basically helps you organize analyses conducted in either non-MEM or RsNLME. It works for both. And this environment really provides a suite of tools that supports the full spectrum of analyst skill levels and analysis complexity. So you don't have to be adding tools or revising tools over time as the skill levels in your function change. And a junior scientist can progress from conducting NCA and Win Non-Lin to command line population modeling in R, all in the same systems. So stability of the systems is key there. This environment is fully supported by Certara. Analysis language tools like R can be notoriously challenging to support. Often it's the business users within a given function that develop environments and kind of write workflows for how they're supposed to be used. And as a result, the overhead to support that often falls onto the shoulders of the business unit. And this can be a challenge. When something's new, it's easy to find people to work on it and recruit people within your organization. However, the maintenance aspect of it becomes a burden. And it's a burden that traditional IT is unable to support because they're not the ones that built these custom solutions with these open source languages. With RsNLME, this environment can be supported by Certara, and therefore it removes some of that administrative overhead from organizations on the support side. And then finally, which we're going to talk about today, is this idea that there's activities beyond the core PMX analysis that are important when you look at the whole job. The whole job of a pharmacometrics analysis starts with source data and ends with deliverables, which include reports, data deliverables, these types of things. And what we're going to see today is an example where the use of RsNLME with our Markdown really adds some efficiency to the report workflow. And you can meet downstream requirements in document format, for example, at the time of document production. So this slide kind of sums it up. When I kind of envisioned what I wanted RsNLME to look like, I had in mind professional tools for professional development organizations, and it boils down to these 4 core elements: capability to support, the simple but also the most advanced job requirements; scalability in terms of solutions that can grow with an organization as well as an individual. Stability is key. A forward-thinking and holistic design plan that won't leave individuals or organizations stranded. When you have solutions that are developed by internal business users, and those users then leave the company, whether they retire or move on, very often departments get stranded because they don't have the expertise to maintain what was originally built. It could be a big problem. And then finally, support. Our support organization continues to develop proficiency in not only RsNLME, but R in general. So our users now, if they have issues with R, used to be difficult sometimes to find support for those types of issues. Certara can really make a contribution there now. So, okay, let's talk a bit about the demo. And the demo that I'm going to cover today is going to be showing an example of how to use RsNLME with R Markdown for reporting. Now, for those of you who are not familiar with R Markdown is a authoring framework for data science. And what it does is it allows you to combine written text, as you'd have in a Word document, and code in a single script to produce a complete document. And in short, it allows you to efficiently create reproducible, high-quality documents in 3 formats: HTML, PDF, or Word. If you visit the link, you can see more about R Markdown. And what we're going to do is we're going to create an example data memo, and we're going to use HTML format. And okay, why HTML? Probably not what you'd want to select for a final document workflow. However, this is an extremely dense document format where you can summarize a large amount of information in a small, very easy navigable space. And the format is such that you can readily transfer it to anyone with a browser. So it's readable by any browser, including a smartphone. So if someone is sitting on the beach on vacation, you get your preliminary analysis done, you can deliver them a report that they can open on their smartphone and read quite easily. We'll also show how to use some of the RsNLME Shiny applications to help with some of the code. And this full demo is available on GitHub. At the link there, there's instructions on how to download and reproduce this whole example. Before I dive in, I just wanted to kind of recap the PMX workflow. So the analysis, if you look at the full job, it's generally a long and iterative process. And the report itself is a consolidation of outputs from different stages of the analysis. And these stages can sometimes be separated by weeks, months, and essentially waiting until the end of an analysis to start a report is quite inefficient. Anyone that has studied process optimization knows that one of the first things that one does when you're looking to optimize a process is identify tasks which tasks can be done in parallel and which need to be done in sequence. The one in sequence, of course, are ones that depend on output from an earlier step to proceed. And what happens is if you're waiting and doing tasks in sequence that can be done in parallel, you're both delaying the time at which you can produce that piece of output, but you also can kind of enlarge the size of your iteration loops. If you prepare what you think is a final output and you discover a problem, and that problem came in at the exploratory analysis phase, you need to go all the way back to the exploratory analysis phase. So if you do these tasks in parallel, you can get great efficiency gains from the overall process. So this is what we're going to do. And essentially what we do is we capture the report objects at the time we create them in the analysis workflow, and we push them into an R Markdown script. And this R Markdown script is then the job, or it's called knitting. You knit the script and it produces a data memo. So you create report elements when the problem is fresh in your mind. You identify the issues earlier than waiting until analysis completion. And the best part is that when you're done with your analysis, there's very little lag time between that final model fit graphic generation to when you produce a report is very fast. And that's where the efficiency gains come in. So if we take a look at, just skip here and take a look at a data memo. And again, what I'm doing is I'm just, the data memo deliverable itself in HTML is an HTML document. And if we take a quick look at this, I'll come back to this, but this is an R Markdown document in HTML format. And essentially you see it's very interactive. You have sections that you can navigate to. You have this document uses something called template tab sets, which allow, instead of a main header and subheaders, you have these tabs. So here we cover conventions used in the document. But to give you a sense for the combination of text and code, here we have a model description. You have goodness of fit plots. So you can see these documents are extremely interactive. We did some target attainment simulation, looking overall and by weight cuts. And again, this HTML document can be delivered to any one of your team members and opened on any browser. So very, very effective way to deliver a preliminary analysis compared to something like a slide deck, with 50 slides in it. So yeah, that's a quick look at our Markdown document. Now I'll jump back to my slides here. This is what we're going to be building. Just to, again, I don't want to give an R Markdown course, but this pictorial summarizes the main kind of theory behind how this works. And what you have within an R Markdown is some code where you use a pound sign to indicate a header level. So 1 pound is a level 1 header. And you see I've typed overview of the data in the R Markdown. This appears here. And we say we want to use tab sets. Then we have a level 2 header with 2 pounds. Summary, you see summary here. We have some text. The elimination profile appears to be by exponential. Body weight and gender appear to influence PK. We've used a star, right, to indicate bullets. So very, very flexible, capability within our Markdown. And finally, the text enclosed in these triple colons with this key message indicator here. Basically, that's saying, okay, I want this text to appear in a green box with this little icon here, with this little shaded, area around it. So it's a formatting thing that allows you to create documents that pop. And again, this R Markdown script is included on our GitHub page, so you can use it as a starting point for documents that you create. You see the next categorical covariate summary, it's level 2, so it appears as another tab. And here we see our first example of what's called a code chunk. And a code chunk is essentially started by this triple backtick, this is called. So lines included between the triple backticks are code. So you combine text and R code. And then it repeats itself. Here you have another level 2 tab, and this is here. And essentially that's it. This pattern repeats itself through the whole document. So it's really not that hard. If you can understand and get to this part, then it just repeats for the whole document. You can write an R Markdown document. You see the code here, we read in a R data object and then we display it, and this is how it appears in the document itself. So kind of quick and dirty, but I wanted to give people a sense for what's going on conceptually, and that's a simple pictorial. Just a couple of final comments on the reporting workflow. If you look at the final reporting workflow, I think people who do this work know that the clinical study report preparation is actually a team effort. It is often managed by regulatory documentation specialists with their own domain tool sets. These folks are experts. I think it's an underappreciated skill in companies in general. What they do is they take inputs from all functions and make sure that they adhere to publishing format that allows submissions to be seamlessly transmitted between regulatory agencies across country boundaries, this type of thing. And when they receive report components that don't follow template standards, it can take them hours to correct that. So in the final workflow process for document preparation, RsNLME can really lend some harmonization to the overall reporting workflow because it allows the analysts to format their outputs at the time of collection or generation in a way that the regulatory document expert can use it directly. So here you see, grapefruit, bananas representing different formats. The regulatory doc experts, translates into an apple. Here's what RsNLME can deliver to begin with. Gives it to the clinical project team, and they generally will send a basket of vegetables back, right, to be reformatted, and you get the idea. And the end is a final deliverable. Now, the use case for today's demonstration is a bit different. It's not final. What it is you might want to use this for preliminary analysis. It's a very common use case. Analyst receives new data and needs to quickly provide preliminary results to a team to inform next steps type decisions. Maybe it's a focus on a key question. Is our new formulation bioequivalent? Is there a drug interaction? How big is it? These types of, the data comes in, we need the answer now, happen quite commonly. And very often the final deliverable process, again, that previous slide workflow is might be too slow. Maybe there's competing project resources for the regulatory documentation expert, or maybe there's logistical issues with the use of that process. Used to be if you uploaded PK data to a database, you didn't always have the blinding control that you needed to prevent unblinding the study. So RsNLME and using this one element of the R universe, R Markdown, allows the analyst to adapt to meet the needs of the team in this situation. Okay, so what I'm going to do now is jump over into an R session and walk through a demo for how you'd actually do this. Now, we've showed a little bit about RsNLME script or analysis workflow in the past. So I'll step through this and show you how we're running the analysis and generating the report in parallel. So I have an analysis script here, this R report example.r, and I have an R Markdown script here, and this is the document script. And what we'll do is we'll start with the analysis script. I'm going to use my code outline. This is very useful in RStudio if you're not aware of this. When you use pound and follow a comment with these 4 dashes, it'll create a kind of outline header in this document outline, and allows you to very easily navigate through your code. Very helpful. So here's where I run a VPC, kind of a minor comment. So we start by loading libraries associated with RsNLME. So there's a group of Certara libraries, and we've also loaded some general R libraries in here, ggplot, gtsummary, which we use to create some tables, tidyr, and that's the beauty of RsNLME. You can easily use it in concert with these other very useful R packages to have a script that contains your whole analysis, and in this case, a report as well. So what we're going to do first is simply read in a PK data set and take a look at it. This looks like a typical, I just show the first 6 lines, typical PK data set. One thing to note is that RsNLME does support character variables within data sets. So everything does not need to be numeric. You can use this analysis data set in NLME. And perhaps the first thing an analyst wants to do is some exploratory analysis, just looking at the data set. So here what I've done is I've used gtsummary. It's a table writing package that here I take my PK data object, I filter it for the first row of time, and then I basically create a sex column, and I make it into a factor where I have factor labels of male and female, and then I summarize this table by center. So if I just quickly run this, and again, this is just from my no RsNLME included here. This is just base R capability using the GT summary package. So you see my nice table here. It's a great package if you haven't checked it out. Now to get this into the report, right? All I need to do is assign this table object that I just created to an object. Here I've called it cat cove sum, and I'm going to create that object. So now I have an object called cat cove sum. You can see it in my files, catcovesum.rds. Create it right here, and I'm going to save it. Sorry, I jumped ahead a bit there. I'm going to save it as catcovesum.rds, and you see it here. So if I just run this object, it's going to show me the table, right? And to get this into R Markdown, basically what I do is I import it here in this code chunk. So let's skip over to the R Markdown document right now and just take a look at that, and then we'll go back to the script and bring it all together. So this is now the R Markdown script, and all R Markdown scripts start with what's called the YAML header, and here you see there's a title. This is basically just laying out some foundation for the document. We have title, data memo example, authors, a date where we actually use sysdate command in R to generate today's date. And then we say, okay, we want a HTML document. There's a style format. The styles essentially are what basically lay out that here you want a gray box, here you want a blue box. We'll take a bit more of a look at that in a minute. And do we want a table of contents? This code folding creates a little button where you can display code in the document. But yeah, that's all I want to say about that. This code chunk here, again, starts with the backticks, is really simply just bringing in the Certara logo. You can change that logo to your company logo. Very easy to do. It's just a PNG file that you're bringing in. And then we start to get into the meat of the document here. So as I showed in the pictorial, here on line 23, we have 1 pound notes and conventions, and we have 2 pounds notes. If we click on notes, we have a text box. This is an example of our Markdown document with a description overview, again, gray box with an eye on it. This text is enclosed between the triple colons and it appears here. So quite simple. The conventions in the document that we use, we've defined some different styles, blue box, yellow box, green box. And again, where these come from, I don't want to get too deep into it, but there's a style file here where you see .description, .results, and then some instructions. These are the instructions that provide that formatting around the document. Looks very complicated, but I assure you, if you have a good template to start with, you can just modify elements of this. So let's go back to here. So here we have our description. We use blue boxes. Results, we use yellow boxes, and key message, we use green boxes. We have a R session setup chunk where here I load a couple of libraries, FlexTable and Plotly, and then we get into our objectives, right? Still no RsNLME in this code yet. It's all our Markdown. So purpose of this data memo, what we're going to do is we're going to provide a summary of an interim population model fit where we then run a simulation and do some target attainment for day 7 AUC 24 and Cmax. That's the gist of the analysis here. But you could see how easily you could take this. I keep using the word template. I don't want to imply that this is the way that you have to do this. Really, it's an example of how we've done it here, and you're free to modify this any way you like, and that's the beauty of the flexibility of R. If you wanted to add another template tab, you would just put 2 pounds and some new text, and it would appear next to methods here, and you could add a code chunk under there or what have you. We get down to the overview of the data section, and this is where we get into tying back into the code that we were looking at. So we have a summary section, right? Key message, elimination profile appears to be by exponential, body weight and gender appear to influence PK, and now we have our categorical covariate summary. And you see we have our cat-cov sum object that we had created, and we're simply read RDS. It reads that R data object, given the file name, and we display it. And what that does is it actually makes it appear in the document. So again, here's where we generate the object, and you can imagine you're working your way through this script, right? I have a complete script to use as a demo, but an analyst would start with this. And as they start here, they like what this table is, and they say, I want to have that for my final report, save it as an object, bring it into your R Markdown document. Now, to generate that aspect of your final report, you simply knit this document. And it doesn't matter if you do that today or 3 months from now, you will be able to reproduce that exactly from your data source. So you can see now that we step through the categorical covariate summary. We have a continuous covariate summary. I use ggplot to create a linear plot and log plot. I also do a faceted by gender linear plot, and then I look at some weight cuts. So I can just run that. We can go back to our document. I'm not going to re-knit it. I knitted this earlier, so nothing in the code has changed, so it still applies. And you can see the continuous covariate summary comes in. I have mean profiles linear, just to show something cool here. You note here in the RMD code where I have my mean profiles linear, instead of just bringing in the object itself, you can actually call ggplotly. So what ggplotly does is it adds interactivity to your plots. So this is a ggplotly display. You can do things like zoom in on plots. You can pan, right? So it's quite cool that you could build interactive displays that your team can then do some kind of fundamental cuts of data, this type of thing. So that's quite handy here. As opposed to here's just a regular log plot. There's no interactivity here, and that's simply by using this command. So now, if you don't know how to write ggplot code, you can always go to an application like ggquickEDA. That is a Shiny app for the ggplot2 package, and will return code. I don't have time to go in and really get into that. So we'll move on with the analysis here. So what I'm doing next is I'm defining my PK model, and essentially I'm giving it a model name, which is a directory name where the model outputs will be stored. And I'm using the PK model function to say, okay, I want a 2-compartment model. By default, the input is going to be IV to the central compartment, so I don't need to specify that. I map to my data variables in the data set and use the model name 2-compartment IV as the model name. I can run this. We can look at the model. Essentially, it gives a summary here. Model overview is population. It's parameterized in terms of clearance, 2 compartments. Here's the PML code. Again, exactly the same PML code that you used all the way back into WinOnLin. You note here that all our initial parameter estimates are 1. We have ADA terms on all the model parameters, so we're going to make some changes to that. And we do that with the structural parameter command, fixed effects, random effects, residual error. So this code might look, again, unfamiliar to begin with, but there's really a handful of common functions that as you use RsNLME, you'll become more fluent in them. Here we are taking and removing the random effect from CL2 and V2. We're giving some initial parameter estimates to the parameters and the ADA terms, as well as the residual error term. You just run that. If we print the model, we can see that all our parameter estimates are up to date now. Yeah, so next thing we're going to do is add some covariate effects to our model. Again, this is a base model. I probably wouldn't be adding any covariates if it was my first look, but I just want to do this for the sake of, for the sake of the demonstration. And here we take the model and we pipe it to the add covariate function. So we're adding a covariate weight onto volume and clearance. And then we are also adding covariates, but not assigning them to any parameters. And what that does is it makes the covariates available for diagnostic plots in the model, right? So now we've added covariates to our model. If we print the model again, we can see that we have our weight effect on clearance and volume, and our ADA terms have been removed from V2 and CL2. Now, we've showed this before, but I just wanted to reiterate here, I've written the code because I know the code. If a user does not know the code, they can always go to the model builder user interface. This is a Shiny app that we've built to assist in the key workflow step of model building. Here you see there's, in this case, we're going to use a PK model. There's many different types of models that are known as built-in models in PML. I'll select a 2-compartment model. One of the new features I did want to point out is, in addition to intravenous and first order, we have now integrated our delay absorption models into this interface. So if you wanted a inverse Gaussian absorption model, you see it adds the correct statements to use a delay infusion compartment and adds the parameters of mean delay time and shape parameter. And these delay functions can be used, for example, in place of transit models, this type of thing. If you're interested in more about that, you can visit our documentation sites for RsNLME. In this case, we'll leave it as a 2-compartment IV model. We covered this before, so I'm not going to go deep into this. Remove the ADA terms. You see the code updates as we go along. And again, the point was, if you don't know the code, you can step through this process of covariates, fixed effects, random effects into, do you have additional columns, steady state columns, mapping, etc. And you can then generate the RsNLME code. And if we look at this, let me see if I can just pop this back up and show it on the same page here. Wow, it's going to be difficult. If you look here, right, you see the PK model command. Is population, parameterization is clearance, right? All these are defaults. This is going to look a lot busier because we include all of the model options available in the PK model command. But when you use it at the command line, you don't have to respecify everything that's default. For example, the absorption intravenous, I didn't specify absorption intravenous because that is the default, and that's what I want. All I had to specify was number of compartments too. But you can take this and copy it right into your R session. And that essentially is this, starting with PK model right here, that's this block of code. So the UI can teach you how to write the code for, at least for built-in models. One of the things we are doing is we're building out a PML model library that covers models that aren't included in the built-in models. So things like, target-mediated drug disposition, dual absorption pathways, that kind of thing. We will have a library that covers how to code that kind of thing. So here I've built my model. I've saved it to a model object. And then you can, the model's been fit. I'm not going to fit it again, even though it's relatively quick, just in the interest of time. We can take a look at the fit here. You can get a summary, an easy summary just at the command line. But what you can also do is either use Expose directly for diagnostics. So here I create an Expose database object, and I'm creating some diagnostics. Here's my DV versus pred diagnostics. If I run that, you can take a look, there it is, right? And again, I save this to DV pred RDS, and then if I come down here to my diagnostics output of my R Markdown, all I'm doing is having my DV versus pred. This time it's a triple pound, right? Going back to the R Markdown document. I know I'm jumping around a bit, but let's go to goodness of fit plots, DV versus pred. Here we go. So the double pound is the Goff plots, right? Base model development is level 1. This is level 2. And level 3, DV versus pred, appears under goodness of fit. Very cool. Again, the HTML format is so dense and can convey such an incredible amount of information in a small space. It's really a useful format for this type of work. So let's continue to step through the analysis code. I won't rerun this. This is all in the example package, but I do some ADA versus weight, ADA versus gender, and there's many, many more diagnostics available in the Expose package. You can see the Expose documentation to, to see what's available there. Next thing I do is I create some run summary tables. So we have an overall run summary table. We have a theta run summary table. I can just run these, show you what they look like. And once again, if you do not know how to write R code for tables, here we're using the Flex table package. Earlier I used GT Summary because it's a very quick way to generate tables. We use Flex table for our applications because of its publishability into Word documents is cleaner than other packages. And why did we select that? Well, if you don't know how to write this code, once again, you can use our applications, our Shiny applications to do this. And what I'm going to do now is just show you how to do that, and that's by use of the Results UI application. So here I call Results UI and I specify my model object. I'm just going to run this, and it's going to bring up, again, this is a Shiny app. Everything is written in R. And what this allows you to do is, for a given model, you can basically select from a menu of basic diagnostic plots. These are all ggplot2 objects. You can see it's very interactive. You can change, point types, point size, right? Use different colors. Not that you'd want to use red, but point transparency, you could add lines. Under layout, of course, you could add reference lines, include smoothing or not. Under layout, you can do things like facet by gender. Again, drag this if you don't like the aspect ratio. Set axis scales to free your fixed, log, your X or Y axes. And under display, you can use default text for the plots, or you also have, the ability to modify the title, for example. These titles use template titles, so that's part of the expose option. The @run will provide a name of the run to compartment IB in this. For example, you can look at template titles within expose to learn more about that. And we have, by default, a Certara theme that's imposed, but this is all modifiable. So you see font sizes, font types, font colors, that is all customizable. So if your regulatory documentation group requires a Times New Roman 12, you can actually select Times New Roman 12 and generate this plot in that format from the beginning, and thereby save them a lot of time with reformatting. Now, one of the things we can do is tag this document. I'll just tag one plot just to show you how that works. But we were working on tables. So down here we have some run summary tables. And if we click on theta, we have a default table for theta. This is modifiable. You can like add or remove column names. We don't want fixed in there, for example. Nothing's fixed. We might want to remove that. You can change the number of digits displayed. This is not significant digits. That is something that we're going to implement, but right now it's just the number of decimal places. You get the idea. You can drag column orders around. You can change labels, change the table caption, and essentially when you're happy, you can tag this. And by tagging documents, what it does is it makes the code and the object available for either pushing into a report, But in this case, since we're working in parallel on another R Markdown document, you see our code here for theta, table, XP object, pipe to get PRLMLE, table, right? Get overall NLME. You can copy this, right? Copy it, paste it directly into your R Markdown document and get your table, right? I think we covered the reporter UI in the past. The other thing you can do with this is, drag these tagged objects and generate a report directly. I'll just do this quickly so you can see. I selected HTML here. You can just open this, right? So that's the document that I just had in the reporting UI. Right. So like R, we support more than one way to do things. So I hope that's clear. You can use this this GUI to actually help you define your code. I'm just going to exit out of here now. I'm not going to save anything. If you're working through an analysis, you'd probably want to save your tag documents as you go through, but I'll just exit. So it brings us back to our code here. So we generate an overall table, theta table. Again, you can see this in the document. Here's our parameter estimates, thetas, omegas, sigmas. We also do a visual predictive check, which is here. So to do that in RsNLME, it's quite easy. There is a VP setup where you basically say, okay, I want 1,000 replicates and I'm going to stratify by gender. In this example, you run the VPC using the VPC model command. So again, I made a copy of my original model and called it VPC model. So here I say VPC model and bring that name in, and the parameters that I want to use are the ones that I defined in VPC setup, which is right here. And you run that, then you abstract the observed data and simulated data from that VPC fit, and you can either write your VPC code directly if you know how to use that. Here we use the tidy VPC package, or like with the results UI, we also have a VPC results UI, and I can just open that and show you that briefly. So here, the input is, of course, your observed and simulated data from the VPC. If we look at the inputs, we have the DV for the dependent variable, IVAR is the time variable. We can select stratify and select gender, for example. And then, you can pick your quantiles, set your confidence. There's reasonable defaults in here. And then under controls, we have several binning methods, including also a binless VPC method that doesn't assume any rules around binning. It uses average quantile regression to additive quantile regression, sorry, to determine how to do those plots. But under binning, we have many different binning methods. I'll just stick with X variable. We can plot this, and here's our stratified VPC plot. And like the results UI, you see we have, layout options, axis scales free, legend position where you want it, all very intuitive. And if you tag this, VPC plot 1, tag it, like with the results UI, under tag, you can select your VPC plot. And if I just slide this over just a little bit, right, you see again, this code that you generated with the UI, you can simply copy this and paste it right into your R Markdown document. So generate this script on the, or this figure on the fly for your document. So this is actually how I built this example. I used the GUI and then copied it in, saved that object as an RDS, and of course back to R Markdown. This should look very repetitive now. But I think that's the point, right? These documents, it might look complicated to you right now, seeing it for the first time perhaps. It's really not that complicated. Here's my visual predictive plot check. Read RDS VPC, VPC plot. And sorry, I didn't mean to open a new tab. And this is where I want to go. Here we are, visual predictive check. Finally, what I do is a target attainment simulation. And here I start with some summary key message. And what I found with my example here is for 100 milligram, once daily times 7 dose regimen, on day 7, we calculated Cmax and AUC, and then looked at percentage of patients above a target Cmax of 1 and a target AUC of 10, and just kind of put some text in there, 97% target achievement, 92% for Cmax, and also to consider a weight-based dose adjustment. Again, this is a hypothetical example, but I think you can get the feel for how flexible this approach is. We have some plots in here, right? Overall, where I've used some tagging to label them, and then we looked at weight cuts. So if you look at 30 to 75, 100%, 75 to 115 kilos, this is weight, 98, but then when you get above 115, your attainment drops to 69 and 45 for AUC and Cmax respectively. Thus the recommendation to consider potentially a weight-based dose regimen. And the code for how I did that is in here. I think we can go over it a little bit, but essentially I use to run a simulation in RsNLME. So what defines the dose algorithm is the database object. So what I've done here, remember I have my original PK database. I need to close my, when you have a Shiny app open, it locks out your R. So I hadn't closed this. So I'm just gonna close that and then this will be active. So here we have our PK data object, right? And what I'm doing here is I'm creating a new data object called PK data sim. And what I'm going to do is filter only the time 0 and then add a column of additional and interdose interval columns to say, okay, I want to give a dose of 100, but then I want to give 6 additional doses at 24-hour intervals. And what that looks at is here. Note that we only need the time 0 row here. We don't need all the times. The simulation times do not come from the data set. They come from the simulation setup. So I've created my data set, which has the multiple dose specification. And then essentially I run the simulation, and in the interest of time, I'm gonna cut it here, calculate AUCs, and then make some plots with ggplot. So I see we're down to about 5 minutes left. I do want to leave some time for questions and answers. So I hope that was useful. Again, a lot of this focused around the use of our Markdown and not so much RsNLME. We've talked quite a bit about RsNLME, and let me go back to my slide deck here. And in terms of where you can find out more, what we've built is really an extensive number of resources that are extremely accessible and interactive. We have this demo is available on GitHub. We have our package down websites for RsNLME. These are live now. These have information on all our packages, vignettes for how to do things, references on functions, installation instructions. Really a good place to go to learn more about RsNLME. We have a package on GitHub now called Certara.R. And this is kind of like a hub for all information around Certara in R packages. So you can go here and easily install all the R packages. Just remember, if you're going to use these, you do need an NLME engine license. If you have Phoenix NLME, that license is free for you. However, if you don't, you do require an NLME license to use these packages. So the packages are open source, but you need the engine. Not unlike needing a license for a non-mem engine, for example. I know there is NLMXer, which is an open source nonlinear mixed effects modeling engine. But yeah, I just want to make the point that you do need the engine. So that's Certara R package. We have an interactive RsNLME tutorial using the RLearner package. This is designed for a novice R and RsNLME user, and it allows really hands-on exploration of RsNLME. And this is without any R or any installation at all. This is a website. So you can visit this website and work through a tutorial and really get hands-on for how to work with RSpeaks NLME. And it's interactive. This code it's real code. So when you run this, you're able to see what the output is. You could go in here and change the code, and so it allows you to work with the tool itself, and it's very instructional. There's a lot of text and talks about how things are done, options, this kind of thing. I encourage you to check that out. And then finally, Certara R School is coming in April. We're very excited about this. This is going to be a series of guided webinars, exercises, and interactive tutorials for the use of RSpeaks NLME and pharmacometrics. And we're starting from the bare bones, how to install R and get set up. And we're going to take it all the way through creating documents like I showed you today and everything in between. So we encourage you to watch for that. Where starts April 27th is our target start date. And yeah, that's going to be a lot of fun. Doing that. So if you're interested in learning, no matter what your level, be ready for that. So at that point, I'll stop. I think I might be a bit over. Do we have any questions?
Hi, Keith and James. Yeah, let's get to some questions. So can you tell me if the HTML output is compatible with Word?
So you can knit documents into Word directly from R Markdown. However, what you will lose is some of the interactivity aspects of it. So instead of having tab sets, you would have actual subheaders like you could imagine in a Word document. Of course, you can always take a screenshot of an HTML document and paste it as an image into Word, but that's how I describe that situation. Yep.
Great. And how would you share this document with your colleagues?
As I showed earlier, it's essentially, I can show my screen again here. It's essentially the HTML object itself. So this is the document that I was showing you. If we double click on this, it opens in a web page, and here it is. So this is again readable by any browser, including smartphones. So pretty cool.
That's cool. Looks like we've got one last question from the audience. Can you let me know where I can find more information about Certara R School?
Yes. So if you well, you can go to this. Where are my slides? Sorry. You can go to our Certara R package. Let me just open that up. And there is a Certara R School tab here. So Certara.R is a package that can be downloaded into R and essentially has information about R School. I know, James, do you have any registration information is going to be available soon on that? So yeah,
yep. Yeah, so registration will be available soon. And I'll just mention as well that Certara.R is available to install from CRAN. And not all of our Certara packages are on CRAN. Tidy VPC is certainly, but some of the RsNLME packages that you've seen today, we manage from non-standard repositories, kind of similar to how the bioconductor packages are handled in R. So you install those from JFrog, so that's kind of our CRAN-like repository that we manage all the builds from. But all those can be installed very easily after the installation of Certara.R from one single command, install Certara packages. And you can actually select which packages you'd like to install, all, none, or individual ones. So, and all the information is available on the website.
Awesome. Thanks, James. Looks like we've got one last question. Where can we get the Git documents such as the code? I'm not sure if that's publicly available.
It is publicly available. I know we do have a link to the repository, so that we will share with you all, and you can just clone that repository and render this report. Now, again, to recreate some of these objects, right, like execute the model, you will have to have the NLME engine installed itself, but users are certainly welcome to tweak this document for their purposes as well.
Awesome. Thanks so much, James, and thanks, Keith. Keith, was there anything else you wanted to show our audience before we wrap up?
No, again, thank you for your time and attention today.
Great. Well, on behalf of Certara, I'd like to thank our speakers, James and Keith, and I'd like to thank everybody for attending today's presentation. This concludes the webinar. Goodbye and have a great day.
Bye-bye, everyone. Thank you.
Thank you.
Bye.